Welcome to Programming with Python session 18. In this session, we are going to primarily focus on object-oriented programming in Python, part A. We have another part B following. So this is just to introduce you to object-oriented programming concepts in Python. Before, mo- Before we move further, I would like to introduce our website, technolearnit.com. You can go through this website and understand who we are and what we offer from the courses point of view and all. And if you want to get in touch with us, there are different means through which you can do that. And I would strongly suggest you to subscribe to this channel using these communication channels mentioned on this page. And most importantly, if you are joining this session for the first time, you should know about this page where the resources that are used for these live sessions are freely available for you to download from this web page. So you can click on any of these sessions and you can get the resources downloaded and you can practice them and become better programmer, right? And also the same page will also have the information about the next live sessions date and time. So this keeps you up to date if you just have an eye on this web page. All right. And the other one is our YouTube channel, Technolearn IT. I would suggest you to subscribe to our channel so that you'll be getting all these updates along with the daily quizzes. So these quizzes will help you to think of the output and also the guess the right output. And I would also strongly suggest you to watch these shorts completely because by the end of this short the answer will be highlighted. So you can also validate whether your guessed answer is right or wrong, right? So with that, this would help you to be in touch with the concepts of this Python programming. All right, and all these questions will also help you to crack the written tests, or any kind of interviews. They would definitely help to some extent. So I would strongly suggest you to subscribe to this channel, YouTube channel Technolearn IT, and get updates. All right. With that said, let us get on to our session now. Assume that you are supposed to design a school management system. When you think of a school, there will be different things that would be coming to your mind. Okay. So what are those that come to your mind when you think of a school management system? You are going to develop some software to manage a school. What are different things that come to your mind? So definitely student is something that you need to think of when you think of a school, right? So student is a thing that comes to your mind. Teacher, of course. A teacher is also important to be in a school. And subject, of course, yes. There can be multiple subjects, multiple students, multiple teachers, so on and so forth. And these are that what we call these as entities. Student is an entity, teacher is an entity, subject is an entity. Okay. I am always using singular number terms here. Remember that. We know that school has multiple students, school can have multiple teachers, school can offer multiple subjects, school can have multiple classrooms. However, we are using singular number terminology here for some reason that you will be coming to know very soon. Similarly, the attendance tracking system, that is a separate system altogether. All right. So, of course, you can extend this to anything else based on to what extent you want to make your software capable, right? But for now, I'll just stop it here and I will just limit the thought process to just these five entities. All right. Now, whenever such things have to be developed in Python or any object oriented programming language like Python, you need to think of something called object oriented programming concepts. What are these object oriented programming concepts is what we are going to discuss. All right. So, what is a thought that comes to your mind if you have to consider storing the details of a student, right? So, if it is one student, probably, and also assume that you just want to store the name of the student, age of the student. For now, only consider two attributes. I'm using the term attributes or properties, I can say. You want to store two details, otherwise, you want to store details of the student. Hence, you can just consider two variables, right? Student1 underscore name is probably a variable name, right? So let me go back to IDLE and show you what I mean. So when you think of a student, I'll quickly open, or let me type in directly. I'll just open a file and I'll start typing here, okay? And if you want to store the details of a student, what you can say is S1 underscore name is, for example, his name is Ram. Similarly, you want to store the age of this student. S1 underscore age is, maybe this is a school, right? 6 years, 7 years, whatever it is. Okay. Now I want to also store the details of student 2. What I can do is I can just create one more variable for him and store the name of that student. Similarly, the student also comes up with some age and I'm going to store the age. What if I have one more student? Yes, I have to follow the same thought process and I'm going to store the name of the student and I'm also going to store age of the student. All right. So this is how I can store the details of students. Correct. Now, what if there are 500 students in the class? Does it mean that for each student, since we are storing two details, so each student needs two variables? Does it mean that if you have to deal with 100 students, you need to define 100 variables? Practically, it is not possible. Or I would say if you have 10,000 students, you definitely need 20,000 variables if you uptake this approach. Correct? So, which is not practical. Hence, what are different alternatives that we can follow in such a situations, right? So, we are thinking something big now. We are trying to build some system altogether. Within that entire system, just a student is one part or one subsection, right? That you need to take care. And if you have 10,000 students, 50,000 students, so on and so forth, if you go with the traditional way of defining variables for each student, that's not going to help a lot. Practically, that's not possible, and it doesn't even allow us to develop such big systems. That is where object oriented concepts will come into picture. And there are many object oriented concepts that we need to learn. And that is a very objective of this session. All right. Now, what are other options available for us, right? Definitely, we understood that this approach is not going to help us, right? Because whenever you know that there is a new student, just creating two more variables for him or her and filling up or assigning the values to those variables is not going to help us at all, right? So what is that we need to do in order to deal with these such situations? And this is very practical. Whenever you think of developing something that is very close to real time, these situations will definitely come. And what is that we need to follow in such situations is a question. So the guideline says that use of object-oriented programming concepts. So what is object-oriented programming and what are those concepts is what we are going to discuss. The very first thing in object-oriented programming is class, right? So what is a class? It is nothing but it's a concept that helps you to club the data or group the data or combine the data. Okay. So a class allows us to club the data and also the functions into a single reusable unit. What does it mean? First thing, when I think of name, that name belongs to a student. When I think of age, that age also belongs to a student. And if I compare two different students, only just the names can be different, but their properties are same. Or the data that I want to capture and save for both these students is same, right? I want to store the name and age of each and every student. So the properties are not changing, but the values of the properties are changing, right? The values of the properties can change, but the properties are not changing here. Properties are always fixed. Once I decide that, okay, these are the 5 details, or these are the 3 details, or these are the 2 details that I want to maintain for each student in my system, correct? So the properties are not going to change, but the values of the properties, meaning here when I say values of the properties, sorry, the value of the property here from the for the first student, the property is name, but the value of that property is Ram. And for the second student, the property is name again, but the property of that value, property of the value of that property is Mahesh. So the value of the property is changing, but the properties remain same because I decide to only maintain 2 details of the student, each student. Make sense? So that is where class comes into picture. Okay, that is only about the data. This is what the data, right? This is the data that we are going to talk about. Of course, a student, when you think of a student in reality, just having the data of a student is not enough. But if you have to deal with some operations that you can perform on that student, you need to have something called methods. So there are two things primarily when you think of anything in the entire world, object oriented programming, right? One is the entity. As I said, entity means what is that I want to really model or what is that I want to really program for. That is the entity here. Student is the entity that I have considered. And the name, age, these are called attributes because those are the properties of the student that I want to capture. So this all comes under the data part. This is the data that I want to maintain for each student. Okay, well, good. But just data is not enough alone because what if I want to update the age of this student 3, or what if I want to change the name of this student because there is a typo, or I just want to change the name of this student for whatever reasons, right? That means those are all operations. Changing the name of the student or changing the age of the student, okay, these are all operations. Not even to that extent, but a simple thing, if you want to print these details of a student, that also becomes an operation. So whenever you think of an entity, there are certain operations that you also want to perform on that entity. If I consider a student, I want to print the details of the student. That itself is an operation. I want to read the details of the student. I want to store the details of the student. That is also another operation, right? So a class is something that helps you to group the data. Data is nothing but the attributes, and the functions, methods, or in other words, operations are converted into functions or methods into a single reusable unit. When I say reusable unit, once you have a class, you can create different number of students. Okay, you can go ahead and create the students. How? We'll look in a second. Similarly, this class, once you define a class, once you develop a class, it acts as a blueprint or the template to create objects. So what is object again? Object is nothing but a variable of type class. All those details we'll look at, but for now you understand that data plus functions is what class consists of. So class mainly focuses on what is the data I need to capture and what are the operations that I should perform on the captured data. These are the only two things that class really focuses upon. In other words, at this point of time, these two are enough for us for our discussion. Data plus functions. These are all put together into single unit, single programming unit. That is nothing but class. Data is nothing but generally we use the term attributes and functions. The functions that we write inside a class are called methods. We'll see this all practically. Attributes also have different names. Some people call them as fields, properties, member variables. Okay, so these are all different names given to the same data is what I have been using. So this class allows a concept allows to implement a concept called encapsulation. Encapsulation. Again, this is a term in object-oriented programming. Encapsulation is the concept, and class is the means through which you can implement encapsulation. Correct? What is encapsulation? Encapsulation refers to the process of grouping or clubbing data and the operations that can be performed on that data together into a single unit called a class. Encapsulation is a process of putting together. What is that you are going to put together? The data and also the operations that you can perform on that data. These two things you put together into a single unit so that you can reuse it and you can efficiently develop the software. That is the concept, right? So class is what that allows us to achieve this encapsulation in object oriented programming world. Makes sense? So far you have been writing the data separately or the variables that we use to store data and all, right? We write it separately and we write some functions, we pass them as arguments, so on and so forth. However, there is a different way of dealing with situations altogether. What you have to do is you have to now start practicing putting that data and the operations that you want to perform on that data together into single unit called class. Okay, so the process of grouping the data and the functions or the operations that act on that data together into a single unit called class is called encapsulation. Very important interview question this is: what is encapsulation and how do you implement? What is a basic programming unit to implement encapsulation? This is the kind of question that can be asked. So your answer should be quite simple, right? A class is a programmable piece of code. Okay, you have to develop a class, you have to write the class just like how you write some code in Python to loop through or to print something from a list. Like that you have to go and implement the class, you have to write some code for the class. What does class support? Class supports the object oriented feature called encapsulation. Encapsulation meaning put the data and the operations together into a single programming unit. We'll talk about that in more details. But how do you create class in Python? To create a class in Python, you need to use a keyword called class, class class, and please make a note that C is lowercase character, right? Class, and then here student means it is a class name. It is the name of the class. Make sense? Like this, you can create as many classes as you wish in Python, right? Okay. So in your school management system, if you have to really develop this entire school management system in Python, you create one class for student, you create one class for teacher, you create one class for subject, you create one class for classroom, you also create one class for attendance. That is how that is one way of modeling this real time system into a programming system, right? All right. So let us go ahead and create our class. Okay. But remember, if you just write this 3 lines of code and try to execute it, you will get error. Why? What does that colon indicate after student and after teacher in line numbers 1 and 3? Whenever you see colon in Python, that means that it is a block of code. It supports block of code. And that block of code is missing here, correct? What is the data? What are the statements associated with class student? What are the statements associated with class teacher? You did not write anything there. Hence, what you can do is you can write something called pass, pass, pass. Remember, pass is a keyword in Python. This just allows us to deal with such situations where I don't know what to write. I don't know how to fill in. I know that I need to write something, but I don't know what to write. In such a situations, you can just write pass pass so that the Python program will not throw any error, but it will run successfully. But of course, it's pass is it refers to do nothing. Don't do anything. That is just to satisfy the compiler that okay, I know that I need to write something, but at this point of time, I don't know what to write or I don't want to write at all. But just go ahead and run my program. If you want to do that, this is what you need to do. Just use pass, pass pass. Not only in classes, when you are developing some functions or methods, right? If you don't know what you need to put in the body, you want to plan, you are just planning, you're just sketching the outline of that implementation. Then you can just use pass. I'll just show that practically now. Let's go back to the program. Okay. Now what I'm going to do is I'm going to first implement a function. Say I just want to write add, add to. Okay. For which I'm going to pass a and b as arguments. Now I don't know what to write, but I don't want to write it now. So you can write pass. Now you pass 1 and 2 and you just write some statement over here just to show you that the control flow reaches here. It's not the program starts, but program execution, right? Because program has already started on line number 1. Program execution starts here and program execution ends here. Make sense? Just for you to show that how the statements get executed. Okay, just let us run this now. I need to save this. 1 second. I am just finding the right path for this to be saved. Python programs, and I can just give some name. Student py. You see, program execution starts here and program execution ends here. What does it mean? These two statements have been executed. It indicates that you cannot execute this statement because you're just following the sequential execution flow. Okay. So if you see this statement and this you see this statement also, any statement that is in between has also executed in the sequential execution flow. Hence, this statement got executed already. Since you did not write anything in the body of this function or you did not define this function, nothing happened. Make sense? This is how you can just write down the skeleton of your program or how you want to implement it, how you want to just outline it, and you can have the implementation later. This is a very good feature that Python supports, and most of the programming languages don't support this at all, right? So this is the easiest and simplest way to follow this approach. Okay. So this is just in the case of a function. I know I need to write some function. I know I need to what arguments I need to take. I have filled in them, but I don't want to write the body yet. I don't want to define that function yet. In such situations, you can use pass. Similarly, in the current case, I know that I need to write some class. I need to define some class, right? To define a class, you should use the keyword called class, and the class definition starts with class keyword and then the name of the class. Here I have considered student as a name of the class. Put a colon, press enter so that you will come to the next line. And here, right now, I don't know what to write. So you just use pass, right? Like this, you can create as many classes as you wish, teacher. But I don't know what to write now. Pass, class, maybe subject, pass for now, right? Now what you can do, yes, this is how you can just go ahead and create the classes in your program. And now I'll just show you that still the program works well. There's nothing that we are doing with this class, but I'm just trying to show you that your program runs successfully. That means the existence of these statements is not going to create any error. Okay, so this is the easiest and simplest way to implement a class in Python. Okay, class is a keyword. Student is the name of the class that you have chosen to give to that class, and just colon is mandatory because a class is a block structure. And then what is that you need to write in the body? For now, you just write pass, and that's all. And let us do some more things here. I want to understand what is a type of student. What is student, right? That's what I want to know. For example, if you have x is equal to 10, if I want to know what is the type of x, I can use what is the type of x is what I'm asking, right? So in this case, you very well know that this says that it is integer because you have stored an integer in x. Now this statement will print class int. But what happens in this case? Student being a class, what is it you will see? Let us run this program and observe that. You see, look at this. Program execution starts here. This is a statement. And when it comes to the second statement, it is just nothing but assigning an integer value 10, integer literal 10 or integer constant 10 to the variable x. Then you ask, what is the type of x? Please print it, is what you said. So it said that it is of type integer, which makes sense. Next, when you have asked for the type of student, it says that it's a type. It is a type. It means that it is a class using which, because whenever you have some type, you can create variables out of it, right? Integer is a class, it is a type, right? And using which you can create some variables. Okay. Ask for what is type int. Okay. It says that type int is a type, class type. So if you have some type available in Python, using that type, what you can do, you can create variables. You can create variables. So when you have asked what is a type of int, it says that it is a type. When you have asked what is a type of student, it says that it is of type. It is a type. It is a class type. So when you have some type available, you can create variables out of it. Not only that, when you ask for a type of teacher, type of subject, it always it keeps answering that it is a class type. Okay. So these are all the classes that you have created. Three classes you have created in this program with no body explicitly defined. That you keep on adding. Okay. So if you try to print the type of the class, then it says that it's a type. Keep that in mind. All right. Let's move on. So you should first understand why I have used pass. Pass is just to bypass the body of any block structure in Python so that you won't get any error during execution. Okay. So if you look at these 5 lines of code, when you execute these 5 lines of code, what is it you get? The output you see is I am here. That's it. Nothing else. Correct. All right. Then what is an object? Object is instance of a class. Okay. Object is instance of a class, or just now you have seen it is a type, is it? No. When I ask for what is a type of class, it says it is a type. Using a type, you can create a variable, as I said. So if you have to create a variable of type class, then obviously it becomes an instance of that class. Okay. In this example, x becomes an instance of integer. Not exactly, because there is some difference, but however, you can assume that for now. Okay. All right. Now you have a class available with you, and if I have to create a variable to that, then it becomes an instance of that class, which is nothing but object. Instance of a class is nothing but object. In other words, a class variable is nothing but object. If you create a variable for a class, it becomes object. Okay. It becomes object. So what is an object? A variable of type class is called object. Makes sense? And every object has its own state. I'll come to that with examples in some time. And it borrows its behavior from its class, that also I'll cover. And it shares the behavior with its siblings. What are the siblings mean? What are the siblings here? Siblings means there is a class, you create one variable and you create another variable. Both these variables, since they belong to the same class, they become siblings of the siblings to each other. Okay, don't worry about all that. I'll cover these in detail. So data plus functions. Okay, who carries this data plus functions? Okay, the definition of data plus functions, like what data to maintain and what are the operations to be performed, class will take care of it, right? And when you create a variable of type class, or when you create an object, each object will maintain the state and behavior. When I say behavior, that behavior or the operations are one and the same. So you can control the behavior of that object by making some calls to these methods. So all those things we will cover in detail. So each object of a class can have its own state. Again, what is a state? I'll give you some examples on the last slide on this. So a class supports encapsulation. An object models a real world entity. An object helps us to model a real world entity, or an object helps us in capturing a real world entity and perform operations from programming. Okay. Object is simply put, object is nothing but a variable of type class. All right. Now you remember we have written a class student, and I have written we have also written a class teacher, and we just kept the body blank because we want to fill in that later, because at this point of time we don't know what to write inside the class and all. So we have just mentioned them as pass. We have used the keyword pass in both the bodies of these two classes. Well, what is a statement on line number 5? It is nothing but creating an object. This is what I just told you, that when you create an object, okay, creating an object. What is an object? Object is a class variable. So to create an object, you have to mention the name of the object. On line number 5, student 1 becomes an object. It's the name of the object. Student 1 is the name of the object. And when I say object, object should belong to some class, correct? Because every object is nothing, an object is nothing but a class variable. That means every object should belong to some class. Here, student 1 becomes object of class student. So if you have to create a variable to a class, this is a syntax. You have to use the object name, then equal to, okay, and then you need to mention the class name followed by braces. Make sense? And if you ask for what's the type of student 1, we'll see this practically, but just understand the syntax here. Okay, what does it give? I have already shown you that when I ask for the type of student, it says that it is class type. Okay, and when you say teacher 1 equal to teacher, teacher 1 becomes object. Object to which class? It becomes object to the class teacher. And you can also check the type of teacher 1, which is an object. So let us go and practice this. So sorry about that. Yeah, you have these classes already available. All that now I'm going to do is I'm going to create objects. So I say student 1 is equal to, okay, student 1 is equal to, I want to make this an object to class student. So what you need to do, I just need to write something like this. Student 1 is equal to student. Here S is capital letter because in my class I have used capital letter, and this is a naming convention that Python suggests us. Every class name must be in uppercase. And if you have multi-word class name that you have to give to a class, then every starting letter of the word has to be in uppercase. So student is just one word and it starts with capital letter here. So when I am going to create an object to this class, I need to use some object name here. You can say X also, you can say Y, you can say Z, anything. But if you have to make it an object to some class, what is that class I want to use here? Student. So student, put braces here. All right. How do I create an object of type class teacher? I can just say teacher 1 is equal to teacher. Here teacher is nothing but the name of the class. Similarly, subject also. If you have to create an object of class subject, this is how you need to write the code. Make sense? Okay. Now let us look at the type of each of these. I could say what is a type of student 1? What is a type of teacher 1? Also, what is a type of subject 1? Okay. As you can see here, let me bring back the code so that you can compare them. Yes, this is a print. All right. So the first one says that the type of student one is student within main module. Okay, because everything is written in single file, and by default, and I'm also executing the same piece of code from here. So it is just all this belongs to main module. So main dot student. That means the type of this student one is student. That means it indicates that student one is of type student. Teacher one is of type teacher. That's what you see here. Under main module, this belongs to, or it's a type is teacher is what it says. Similarly, subject one belongs to subject class within main module is what it says. And finally, it has printed program execution ends here. Makes sense. So this is how you can first create classes, as many number of classes as you will, and then you can go ahead and create objects. How many objects did I create here? Three objects. Do these three objects belong to the same class? No. Each object has its own class. So student 1 is an object of class student. Teacher 1 is an object of type of class teacher. Subject 1 is an object of class subject. Okay. And when you ask for the type of this, it indicates that these belong to their respective classes. When I ask for student 1, it says that student 1 belongs to student class within the main module. Teacher 1 belongs to teacher class in main module. Subject 1 belongs to subject class in main module. What if I write a teacher here? Then subject 1 also belongs to, subject 1 is an object of type teacher. That means subject 1 also belongs to teacher class only. That is a thing that happens. So what is that you are using on the right hand side of this assignment operator matters. What class name are you using on the right hand side? Accordingly, the left hand side variable will become object of that particular class. Okay, so I'll just change this to subject so that it will be very relative. All right, so this is how you can understand the type of objects. Okay, when you ask for the type of class, it says it is class type. When you ask for the type of object, it reports the respective class name. All right, let's move on. Okay, now assume that you have two classes, and this is this is what you have just seen. So here student one becomes object, teacher one becomes object. So to define or to represent a class, what we do is generally we represent it like this. This is a UML diagram. So on the top, you have to mention the class name, which is student in this case. And what is this minus? I'll talk about it in some time. Roll number is nothing but attribute that you want to capture within this class. Similarly, you want to also capture the name. You want to manipulate, or you want to save the name of that student. You want to store the age of that student. And after colon, whatever you see, those are nothing but the data types of those respective attributes. Roll number, I am treating it as a string for now. I'm treating name as a string, and I'm treating age as integer. So these are the details that I want to really store within this class. So roll number, name, and age. What these will become if you put or if you associate them with to a class or if you write them within a class, they will become attributes. Okay. Attend class, study, revise, write exam. What are these? These are nothing but the functions that you are planning to put within a class. Then a function that is written within a class becomes method. It's just a terminology change. That's it. Okay. If you write a function outside a class, that means a function is nowhere related to a class. Then we just call it as a function. That's it. The same function, if you put inside the class, then it becomes method. So attend class is a method, study is a method, revise is a method, write exam is a method. And whatever you see of colon the none, that is nothing but the indication that these methods return nothing. That means they are not going to return anything meaningful to you, right? If you add two integers and if that function returns back an integer, then the return type would be int, right? We can assume that way. But here this clearly indicates that these functions will not return anything. That's why that none is what has been written there of colon. Makes sense. What is student here? It's a class name. And whatever you see this, right? Roll number, name, age, these all are nothing but attributes. Attributes, right? Attributes are the one that describe the class and the entity that class refers to. And whatever you have written at the bottom, those are nothing but methods. So attributes will be written inside the class, methods will be defined within the class. Makes sense. And attributes are used to maintain the state of an object, while methods are used to control the behavior of the object. Okay. Don't worry about this terminology. I will show you all these things practically. But for now, you understand that a class can contain some attributes and methods. Attributes are used to capture or store the state of a real-time entity, and behavior can be controlled through methods of that class. Okay. Similarly, you can model your teacher. You can just write a class diagram very similar to this teacher. Then on the top, you should write the class name as teacher, and whatever the attributes or the details you want to maintain for for a for a given teacher. Don't be very specific. Okay, you should be very generic. When I say student, I did not refer to student Ram or Shyam here. I just have written or I have something in my mind that in general, what is that I want to capture from the student point of view. What are the details of the student I want to capture is what I have just thought, and I have just simply mentioned the names. I mentioned the variables here. Those are nothing but attributes is what we call. Okay, these are kind of variables only, but they are kept inside the class, so they become attributes. And attributes are used to maintain the state of an object. That comes later. Once you create a class, once you define a variable to this class, that becomes an object, and the state of the object can be maintained within these attributes. Okay, and the operations is what I call. If you have to perform any operation on an object, then you need to call these methods. Okay. All right. So if you think of a student, you can refer to his roll number or her roll number, and you can also maintain the name of that student. You can also maintain the age of the student. These are the three attributes, or these are the three details that I want to maintain at this point of time. So those become part of the class. And what a student can typically do from studying purpose, he can attend the class, right? That is his action or the operation. Okay. So all these actions, operations, or his behavior, all these things will be controlled through methods. So for each behavior that you want to capture, or for each behavior that you want to control, you need to have one method, right? So attending a class, right, that becomes a method. Study means a student will study, right? That becomes a method. Student will revise the concepts. So revise is a method. Student will also write exam. So write exam becomes a method. If you understand this carefully, the attributes are generally nouns. Roll number, name, age, these are all nouns. And when you look at the methods like attend a class, it refers to some action, operation. So that is the key difference between attributes and methods. By looking at it, okay, one can understand. Study means here, study as a verb, okay, and revise. Revise is also a verb, and write exam. It's nothing but action. It refers to an action, right? So this is how you have to think of a class. So class will have some name. It will have some attributes. It will also have some functions, but we should not call them as functions, but you should call them as methods now because they belong to a class. So what you can write inside a class? You can add some attributes to a class, and you can also add some methods to that class. And these methods act on the attributes. That is very important. That is how you are relating the things together. These methods will act on the attributes. And a very simple analogy here is how do you really understand the difference between class and object? Class is just a blueprint, or it is just a plan which is on the paper which is not executed yet. Similarly, when you have created a class in Python, you have some idea, you have some thought in your mind and you have implemented it. But there is no memory allocated yet, or there is no physical presence of that plan. So that is where the object comes into picture. So you see, using that same plan, there are three houses constructed, for example, right? So each house which is a physically available for you becomes each house becomes object. So class is a blueprint is what we have seen in the definition of the class some time back. Blueprint means it is a plan or it is a template which is not physically available, but it is just a thought that you have put in your program in the form of a class. You have defined it. And when you create a variable of type class, that is nothing but object which is physically available in the memory. So that is a key difference between class and object. Class is a concept, object is a reality because it really exists in the memory. Okay. So here each house becomes one object. Okay. You have created three objects of this class to put it simple. Okay. And you see each object has its own properties. When I say own properties, the values of the properties I mean. So when you look at first object, the color of the house is light yellow or yellow you can say. The color of object 2 is blue or light blue. The color of the object 3 is purple, right? So class is a concept, and once you implement it, right, those things will become objects, and each object can have its own values to the properties. Don't worry, we'll look at all these things practically. So look at this now. I have a class and I have created one object to that online number. What's the class name here in this example? The name of the class is student. And what is student 1? Student 1 is an object of student class. And when you have printed the type, what is it you get? You get that it would be under whatever main module, and then it will give you student. And you have created one more object to student. You look at it carefully. You have created one more object for the same class. Okay. So student 2 is another instance of this class or another object to this class. And type of student 2, again, same output you will get under so and so, generally main module. And it just gives you that it is of type student. Student 3 is also same story. So you have created multiple objects of the same class in this example. You have created multiple objects of same class in this example. You have only one class, but you have three objects created. What are those? Student 1 is an object, student 2 is an object, and student 3 is an object. All these objects belong to the same class called student. All right, fine. Now let us go and understand how to create attributes, how to add attributes to a class. What is a class? Class is a combination of attributes and methods is what I said. Attributes and operations otherwise. So first let us understand how to add attributes to a class. For now, I just have an empty class just like this, and I just go ahead and create an object to it. Student 1 is equal to student. Student 1 becomes an object of type student, but the class student does not have any attributes. So what you can do is you can just add the attributes now to the object. Through object, you can add attributes to that object, right? So student 1 is object, student 1 dot name is equal to Ram. So here name is the attribute that you're going to add dynamically to this class, right? Student 1 dot name is equal to Ram. If you want to add one more attribute, student 1 dot age is equal to 6. If you want to add one more attribute, student 1 dot whatever that attribute is, marks or height or weight or p or date of birth or gender or anything it could be. This is how you can keep on adding as many attributes as you wish dynamically. Once you create an object, we are doing this. So if you just go ahead and print student1 dot name, it reports it as Ram. And if you print the student age of the student, keep an eye on the dot operator here. On the for the dot operator on the left hand side you have the object name, and on the right hand side you have the attribute name. So while printing also you have to refer to that object name dot attribute name syntax. Student1 dot name, student1 dot age. And if you ask for what is the type of student1 dot age, can you guess what happens? What it reports? Student1 dot age. Student1 dot age. What is its a type? It's nothing but simple integer. All right, let's practice this now. For now, I'll keep continuing with only one class, right? Okay, I have only one class. I created the object to that class. Okay, now I'm going to add attributes to it. Student one dot name is equal to something Ravi or something. I add one more attribute now. Student one dot age is equal to 6 years. Okay. So you see what I did? I was create an object and I keep on adding the attributes dynamically to this student. And you can now go ahead and print student one dot. Okay, from student one, what is that you want to capture or what is that you want to look at? Name, for example. I want to know what is the name of this student. So you can print student one dot name, and you can also print student one dot age. All right, and let us run this now. You see program execution starts here. Well, So this line of output program starts here has come from here. You have created an object, nothing happens on the screen on the output. You have assigned Ravi to student1.name. Here you have added the attribute name dynamically to this object. There is no any difference in the output. You have added one more object, one more attribute to this object student1. The attribute name is age. Dynamically you have added, no difference. When you have printed or accessed, retrieved student1.name, it has to refer to Ravi, and because it is a print, it has printed Ravi here. Next, student1.age, this is what you are referring to, it is 6. So 6 is printed here. After which, this is a statement, simple output statement. So it is what you can see here in the as a last statement of the execution. Make sense? All right. So this is how you can keep adding attributes to the object dynamically. Dynamically meaning while writing inside the class, I don't have any attributes, but I have just added these attributes on the fly dynamically, right? So that is what we call this method of adding the attributes dynamically, actually, right? So you are adding them dynamically, right? And what if you try to access some attribute that is not present? Student one, you have name, and line number 4, you have added that dynamically. Age, you have added dynamically, but okay, accessing name and age makes sense. But when you have asked for also printing the marks of this object, first of all, this object doesn't have an attribute called marks. Hence, this results into an error. Let us try it out. I'm also going to print something that is not present. I want to print the marks of this student. Run this. As you can see here, it was able to print partial output, right? Program execution starts here. Well, that is expected. Then it prints Ravi because of this statement. It prints Ravi because of this statement. It prints 6 because the age of the student one has been stored as 6. So that is what it is able to access. When it tries to access marks, there is no attribute called marks in relation to this object student one because that has never been created. Hence, you see an attribute error. Student object has no attribute marks, right? This becomes attribute error. Okay, this is attribute error. All right. So we should be careful when you are adding the attributes dynamically. You cannot access an attribute that's not present. First of all, so this results into an error. Okay, this results into an attribute error. Okay. All right. Again, I have a class, but with nothing in it. Then I create an object of the same class and I have added name to that. That means I have added attribute name and the value of this attribute is RAM. I have created one more object S2 and I have added a dynamic attribute called age. Dynamically I have added attribute age and I have assigned the value to that attribute as 6. And when you print s1.name and s1.age, what is it you get? You get error. Why? S1 as an object has only one attribute called name. It doesn't have an attribute by name age. So that gives an error. Similarly, when you try to access the attribute name of S2, that throws an error. Why? Because S2 is an object that has only attribute age. It doesn't have any attribute by name. Hence, this program or this piece of code produces error. Let us try that out quickly. You have student, you have name stored, you have, there is only one for now for this guy. You have created one more student. You have created one more object to class student. And now student2 dot age. See, I'm dynamically adding the attribute age here, and it is 6. Now while printing, I am trying to print the name of the first student, which makes sense, and student1 dot age, which is non-existing one, it throws an error, right? Because right now I don't have age on student1. When it comes to student2, I am trying to print a name and age, very similar to upper one. But what happens now? Error. In this line also you have an error. Why? Name is okay, because for student1 you have name, but you don't have the attribute age. So this is one error. If you fix this, you'll get one more error on the next line, because the student 2 has only age, but he doesn't have, or he doesn't have name. But you are trying to access a non-existent attribute. Okay, so that's the reason you will be getting these errors. You forgot the comma. Where is this line number? Oh, here. Oh, here. Sorry. All right, you see here program execution starts here, but you see an error. What is error again? It is attribute error. Student object has no attribute age. It describes it very well. Student attribute does not have attribute by name age. This is for whom? This is for student one, because student one had only name, and when you are printing the name as well as age. Non-existent attribute you are trying to access. So I'll comment on this. Does the program work well now? Not really. It gives you attribute error once again. Why is this attribute error again? Because student 2, you have captured only age of this student 2, but not the name. Hence, this results into an error. And if you eliminate this, now this should work. It should print what? 6, because student 2 dot name. You have assigned 6 to that, so you should get 6 now. You see, you got 6 here. Between these two statements, program execution starts here and ends here. Makes sense? So it is very dangerous to use this mechanism of creating attributes dynamically. Though there is an option provided by Java, what happens because of this? Okay, two objects of same class can have different attributes. So you cannot write a generic piece of code. So what is a solution for this? So in case of student 1 or S1 in this example, you'll be getting error for s1.age. In case of s2, you'll be getting error for s.name, s2.name. Both errors are attribute errors only. You are trying to access an attribute which is not associated with that class or the object. That's the thing. So, and remember, it is not recommended to use this mechanism of adding attributes dynamically in Python. Python doesn't allow us, sorry, of course, Python allows us to do this, but it doesn't recommend to do this. Why? You know the reasons. I just explained it. If you apply this mechanism to create objects and add attributes dynamically, all the attributes, though they belong to the same class, may not have all the attributes available within them. There is no uniformity. For student 1, some attribute is available. For student 2, some other attribute is available. But if you want to access both these details from both these students, it's not possible because at least some data is missing over there. Makes sense. So what is a remedy for this? Use constructor. Yeah, the remedy for this is to use constructor. What is a constructor? So constructor is another concept in object-oriented programming. So again, let us understand what a constructor is. So you have a class. Within this class, you are defining a function. DEF means you are about to write a function. But here, since it is inside the class, call it as method. So what is that underscore underscore? Underscore underscore is reserved for Python variable naming convention. So, but here you have to still use underscore underscore init underscore underscore. That is the name of the function or the name of the method is what I would say. And within the brackets, it's a function or the method. No, so it has argument. It may take arguments. So here cell is what the argument is. And when you print, I am here. Just I'm trying to show you what this init is. Okay. And you create an object of this student class. You create another object, then another object, another object, another object. So total I have created 5 objects of class student here. Starting from line number 5 to line number 8, I have created 5 objects of class student. Okay. What happens now? So I'm going to first write some code very similar to what you see there. What is it? DEF. No more pass because I know I can write something inside the class now, right? Init and then cell, right? What is what I want to really do inside this init? Okay, init is a function. I'll come to that. I just write some print statement here. Print I am here like this. Right? Now I create this object. I don't want to add any dynamic parameters or arguments. I create second one. I also create third object of the same class. Okay. I have created 3 objects of same class student here and I have something written inside this class. Don't worry about the meaning of it, but I'm just running this program. Observe the output carefully. It has printed I am here thrice, 3 times. How and why? Who has called that? Right? Who has called that function? Though there is some function available in your program scope, if you don't call that function won't get executed. Correct? When the function is not getting executed, how come you can see the output printed from this method? So that's a beauty in Python and other programming languages, especially that support object-oriented programming. What is that you have done here on this line? You have created an object. Again, you have created an object. Again, you have created an object. When you create an object, automatically, this method would be invoked. That's why it is some special function. It has some special feature, and this is called construct, which is called constructor. For any class, the constructor name would be one and the same. What is it? Underscore underscore init underscore underscore. Okay. what is a self? I'll come to that later, but for now, that is what it is. And you can write anything. It is a function now. Function is nothing but it's a method. To be more precise, method is nothing but a function. So you can fill in whatever you want inside that function. And then when you execute the program, automatically what you can see is the body of this constructor is executed. There is no explicit call that you made. However, when an object is created, automatically the constructor would be invoked. Automatically the constructor would be invoked. So that is what the current output proves, right? I have just created three objects and I can see this message coming thrice. Where is this message coming from? Which method or the function it is coming from? It is coming from this place only. That means this got executed for how many times? Three times. Why three times? Because I have created three objects of this class student. If you had created more objects, obviously there would be more coming out, more output statements coming out, because every time I create an object, this method will be automatically implicitly called. All right. So in this example, we have created five different objects. Okay. So I am here would be printed five times. Okay. So this is called constructor. Okay. The name of the constructor of any class is nothing but underscore underscore init underscore underscore. It's a special function or the method. Okay. Which is used to initialize the values of the objects. What is meant by initialization? So here init is a constructor, right? Well, the very first problem that we have been seeing is that while adding attributes dynamically, some methods would be having their own attributes and the other may be having their own attributes and there may not be any overlap. And how does this class concept solve that problem? So let us look at it. So you have a class by name student and this is a constructor. This is called what? Constructor. And this constructor takes two arguments at this point of time. One is self and the other one is name. And you want to store whatever user has passed as a name. Okay, you want to store it inside this class. For that, what you have to do, you have to use self dot name. Very important. Self dot name is equal to the incoming name is what you mentioned. Okay, well, now I am going to create an object now for this student class. S1 is equal to student, and remember what is the term in the brackets? That is nothing but the argument. Okay, so basically this is a parameter that you pass RAM, and the argument will be name actually within the init. Okay, now what happens when I pass RAM? It gets into name variable. From name variable, it will be moved into self dot name, meaning it will get into the class and it will create an attribute for that. Make sense? I have created one more object, but this time I have passed a different name. Now what happens? Now that self refers to object S2 because currently S2 is the object that was created. So whichever is object is being created at that point of time, self will point to that. So S2's name would become Bhavana. Okay. Now if you print S1 dot name and S2 dot name, you can see both Ram and Bhavana printed. And this is another way of calling this constructor. You can explicitly call the constructor. Explicitly calling the constructor meaning what is the name of the constructor here? Underscore underscore int underscore underscore. So you are going to call that underscore underscore init underscore underscore using S2. Okay, S2 dot because this Constructor is just special member function, right? And a method otherwise. And that method you are calling using object. And after that, what happens when you are printing s2.name once again? Earlier it was what? On line number 6, s2.name would be Bhavana. After you execute 7 and 8 lines of code, you will be seeing that the name has been changed to Bhavani. Make sense? So this is how you can explicitly call the constructor. Okay, you can explicitly call the constructor. So whatever data, whatever you have been using for initialization, that you can put in the constructor, and that constructor will take care of putting that initial value into that. Make sense? And you can pass multiple arguments to constructor, and this is an example for that. Name and age is what you are passing. So you can create two attributes. Where are you creating attributes now? You're not creating them dynamically. Okay, when you create dynamically, there is a chance that your attribute won't your object won't have that attribute at all. But this way, if you are using constructor, what you can do, you can pass all the values of the attributes through some arguments or parameters, and using those arguments we will be creating the attributes within the constructor, and they will be available for your object. And remember, since a constructor is invoked for each and every object, using this approach there won't be any chances of some objects having some attributes and the other objects not having those attributes, because every object creation gets through this constructor. So constructor is a place where you are going to initialize the attributes, right? So what is s1.name and s1.age? s1.name would be ram. You see there on line number 5 you have used ram as a name. 6 is a age, so it will be printing ram and 6. And when you try to print s2.name and s2.age, it would be shyam and 7. And you are going to create another object s3, but you have passed only the name component, you did not pass the age component. So what happens when you create a constructor? This is another important question from interviews. What happens when you create object for a class? Constructor will be auto invoked. In this example, Mahesh is what you are passing. That means Mahesh becomes the name, but you did not pass age. Hence, you will be getting an error. So it says that missing positional argument, mandatory positional argument is what it says. Okay. Yes, we have made a good progress that we have created an object. Sorry, yeah, we have implemented a constructor, and the constructor is what will take care of the attributes associated with that object. Since this constructor is invoked for every object, now you can be consistent with having the same attributes in all the objects of that class. That's a beauty. So don't add attributes dynamically, okay, to any class or to any object, but just add them through constructor. So this is the initialization part where you initialize both name and age to attribute corresponding to the current object that has been invoking the current or that has been being constructed. So since you get an error in the last line where when I know that the age will be by default 6 for anyone to join that class, okay, most of the times I need not pass this age explicitly, so I can make it as a dynamic sorry, default argument. As I said, constructor is nothing but a special function. So for a function, you can pass default arguments. Similarly, you can also pass default arguments to constructor. What is a default argument here? Age would be the default argument. So age is equal to 6 is what I have given. inside the class during definition of the function. So that becomes the default argument. And now self dot name would be name and self dot age would be age. Whatever age that comes in, that becomes the age. And you create an object to student, object of class student, that is S1, and you have passed it two arguments now. With this, what happens? There will be an object created by name Ram and by age 5. When you print S1 dot name, you should see Ram and 5 as age, right? Ram and 5 should be printed with single space. Now, if you create one more object S2, but this time you pass only the name, but you did not pass the age, still no problem. Earlier you were seeing the error there, but now you won't get an error because you have implemented the default argument in the constructor itself. So for S2, the age becomes a 6. So when you print S2 dot name, you can see Mahesh, and when you print S2 dot age, you can see 6 coming out, though you did not pass the age component to this function. All right. So default arguments are applicable in constructors as well. Okay, here is the default argument and the value to the default argument is 6. Installation takes place in constructor, a special function in any class. Okay, what if you have to add more and more methods to your class? Okay, so here look at it. I have an constructor. I have a constructor in this class. I also have something called display. What is this display? Let us see. Display is another method that I'm going to add to this class, right? Before I move ahead, let me practically show these things to you. So you have init and say for example, I want to store the name and age of student. I need to pass both of them as argument in addition to self. Now what should I do? How can I add these attributes? By mentioning self dot name is equal to whatever the name that comes in. Similarly, self dot age is equal to age. Make sense? This is how I have created the constructor. Now, but remember, I have to pass these two arguments. I have to pass name first and then age. For this guy also, similarly coming to this, I can say 5 years. All good. But if I have to really understand what has been there in these objects, I have to print what student one dot name, student one dot age. You can repeat this for other two objects as well. All right. So the expectation here is for this line of code, you should get Ramu and 6. For this line of code, you should get Mahesh and 7. For this, you should get Bhavana and 5. Let us run this. Yes, Ramu and 6, Mahesh and 7, Bhavana and 5. Right? What if I try to create one more object? Student 4. Student 4. But this time, mm, I call student, but I pass only name. Okay? I pass only name. I did not pass age. I did not pass age. And if I try to print the details, Let's try that out. This should give you an error. You see the error? Again, missing positional parameter, age. That means it expects that value. Okay. It expects the second value also to be passed. This is not possible this way. So to avoid that, what did we do? Since we know that it is LKG or whatever, LKG or UKG students, you can just define define the default argument, or you can provide the default value to this argument. What did you say? You said that, see, if you don't pass anything, I treat the age value as 6 is what you have mentioned here indirectly. And in such cases, Harita will also continue to work. No error now. You see, Harita, the age has been assumed to be 6, which is a default age coming from that constructor. All right. So this is how you can have default values and all that. Adding more methods, right? Let's go back to the program. And inside this class, now you see this class student has some function, one function, or the method is what I should call precisely. That too, this is a special method. That's why I call this as a constructor, because this will be implicitly called whenever an object is created, right? Hence, this is a constructor. What if I want to add more and more methods to this? You can, of course, do that very well, easily. And I just want to print the display. I want to display the details of these students whenever needed. But remember, I need to pass self. Sorry, let me maximize this. Okay, self, and then what? Print self dot name age. Okay, and you can just call student one dot display. All right. So you have student one dot display, student two dot display, and student three dot display. Sorry about this. Okay. Now what is display here? Display is another method. Since it is inside the class, it becomes a method. So display is a method, right? Display is a method, and you have instructed to print the name and age of the object. Run this. You see, everything has come as earlier, right? Okay, Bhavana has an age of 5. Does it make sense? Bhavana, you have explicitly passed a 5, that's why. Which makes sense, right? So what did we do now? All displaying the details of the students has been, that responsibility has been given to display function. But since this function is inside the class scope, we should call this as a method. So student class has a method called display. Okay, student class has a method by name display, or student class has display method inside it, right? So to call a method, you should use dot operator. For this dot, left hand side you should have the object, right hand side you should have the method name. Okay, and student one dot display, student one has Ramu as a name and 6 as a age. Student two dot display, when you call student two dot display, automatically this self will refer to the current object that has been used to invoke or call that method. So self becomes student. Makes sense. So this is how you can keep adding more and more methods to the class. Constructor, very helpful. You should always treat it as a must. And methods, up to you how many methods or operations you want. These methods are nothing but operations. Whenever you want to display the name of the student, sorry, details of the student, call the operation display. Call the method to display using that object. That's all. Would give all that. Okay? So that's what we're trying to understand here. Adding more methods. So yes, you have this, and now if you have to print the name and age, for that you can give that entire responsibility to display function, and then you can create an object. On line number 7 you have created an object by values ram as name and 5 as age, and when you say display, see, look at the syntax how we call a method. To call a method you need to have object here s1 dot dot is a syntax notation, display is a method name. So if this class has 5 different methods, which method you want to call, because which operation you want to perform, right? So based on that you need to name that corresponding method that you want to invoke. All right, so we have been using self. What is that self? Self is the very first argument that you have been passing every time now. For a display also, last time when you see, or if you go to the code, I was using self here. I was using self here. And this self is always the very first argument for any method that I am writing. So I have written so far, right? What is this self, right? So should I always use self? Is it a keyword or something, or is it a standard? Let us understand that. In fact, instead of self, you can use any valid variable name. This is an example where I have used x in the constructor in the place of self, and in the place of self in display function or the method I have used y, a different, completely different name I have used in the place of self. Till the program works, but only thing you have to do is wherever you have been using self, you have to replace it with the first argument variable name. So x dot, since this is x here, x dot name, x dot age. In display also same thing, but in the display what is the name of self? Y. So you should use y dot name and y dot age. That's all. Rest of all the same program. You can create an object and you can also call display function, and that's all. What is a self is what I'm going to explain you in next slide, but let me show you this practically. So I don't want to use self at all. I want to use some another name. You can give any name there. Okay. Now inside this you should use x. Inside this you should use x because now it doesn't know what is self, right? You can maintain space between the methods inside. Okay, y. Now this is y. So this should become y dot. This should become y dot. And that's all. This should run. Same output as earlier. Yes. This works very well. So what is a self? Self is not something that you should always use the name as it is. You can use any name in the place of self. It is just a placeholder. That's it. So what happens and what is the importance of this self, or why we should pass this first argument always as something that system uses it? Okay, we are going to understand that. So you see in the constructor I have used x in the place of self, but it still works. Similarly in display I have used y in the place of self, it still works. Only thing is whatever the name you have used in the header, the same name you have to use in the body when you are referring to the attributes. That's all. However, though you can use any name in place of self, but the recommendation from Python is to use self always. Don't use any other name because 99% of the Python community uses a self only. They don't use any regular other names. So you should also use self. But you should also understand that The name of the self need not be self always. You can pass any name to that. All right. Now look at this piece of code. Well, this is a constructor and this is a display function. And you have created an object by name as Ram and age as 5. And look at this carefully. This syntax is very important for you to understand. S1 has Ram and 5 in its attributes. Name attribute has 5 value. Age attribute has sorry, a name attribute has a Ram value and age attribute has value 5. Student dot. First of all, is a student an object? No. So far we have been using objects only on the left hand side of dot operator. But for the first time we are using class name on the left hand side of dot operator. Perfectly fine. Student dot init. Init is a function right inside the class. Constructor to be more precise. And you have passed two arguments. Sorry, three arguments. S1, Ramu and 6. So S1 refers to see these are the parameters that you are passing and the arguments are x name and age, right? So S1 will be copied to x, Ramu will be copied to name, and 6 will be copied to age, right? So in such situations, the name doesn't matter. No, the name of the actual arguments and the name of the formula arguments need not be matching. If you put x, you are passing x, you can capture it into y. Only thing is the data type is important, right? So here also the same story. Remember, this is another way of calling a constructor using the class name, not object name. So first you understand till this portion. For this practically what I'm going to do is I have one object for now, and once I have that, what I'm going to do is I'm going to call what is the name of the class? Student. Student S capital, okay, dot. I'm calling the init function like this. By passing student 1 as a first argument, then the name of the student, then the age of the student. Maybe I'll change it. Now you go ahead and print and see what is there inside this student 1. Okay. You can also print student 1 just before you do this experiment. You can print here as well. Or you can call student 1 dot display. Okay. Student 1 dot display here, student 1 dot display here as well. But you have called the constructor again here, and you have passed the student 1 as a first argument, and then you have changed the name and age of these two guys. Ravi has to be closed here. Okay, all right, let's run this. Okay, you see here, wow, used this constructor to store Ramu in name and 6 in age. So you see Ramu and 6 coming here. When you have displayed student 1 dot display, it has been able to print Ramu and 6. Then what does this do? This init function or the method when you have a call using the class name dot syntax, student 1, that means object has been passed as a very first argument. Object has been passed as a very first argument. Then the rest of the two arguments have been passed. For the name you have passed Ravi and for age you have passed 7. What happened was this is student 1 refers to x. So x dot name meaning the name associated with student 1 which has been Ramu so far has been overwritten by Ravi. Similarly, the age part of student 1 has been updated with 7. Earlier it was 6. Then when you have asked for a display, okay, when you have asked for a display, you didn't pass anything here, but automatically student one will be passed here. So student one, this name of, because it has updated to Ravi, you can see Ravi in the output. And 7, the age also updated. That's what you see Ravi and 7 as output here. And then finally program executes ends here is what you can see. All right. So this is nothing but this is a way to explicitly call a constructor. If you really want to call a constructor explicitly by yourself, you can use this syntax. But in general, whenever you are creating an object, constructor will be automatically invoked behind the scenes. Okay. Now, if you are able to call any method like this, can you tell me what is the equivalent way of calling this, writing this statement? What is, see, earlier you are using this as syntax, no? So now if I want to do that using student one dot, sorry, student dot, tell me, student dot, there is no student, sorry, student class name dot display, and you should pass student one as a argument. And do you need to pass any extra arguments, because it takes only one argument, that our single argument is nothing but object name. So this is how internally Python will, you can see this being printed twice. Why? Go to the code and understand. You see what I did? Yeah. This display will print Ramu and 6. So this is responsible for printing Ramu and 6. Then I have changed the values to Ravi and 7. And this first Ravi and 7 is what you see here came from this in this display. Then I have also called student.display. Here student is the class name dot display, but I have passed student one as an argument. When I have passed student one as an argument, student one's name got updated to Ravi. So you see Ravi here. Student one dot age has been updated to 7 because you have updated here 7, and that's what you see in the latest display. So this is how you can understand that these are different ways of calling the methods actually. One way to call the method is directly use object dot syntax. The other approach is you can use the class name itself. The class to which this method belongs to is student. So here, sorry, student dot display, but you need to pass the object as argument. Then if this function has single argument, that means it itself is self, or it refers to the current object that has called that display. All right, that is all about that. And the other way of calling this display is just student, just I have shown you student one dot display, and you pass object as argument to that display. Okay, so this still works because it is just you have just changed the name. Okay. And if you want to add more and more methods, right now you have only two methods, out of which is one of which is constructor anyways, and the second one is display. But if you want to keep adding more and more methods to that class, you can of course do that. Write as many operations as you wish. Right? Write as many operations, implement as many operations as you want to support on that data or the attributes. So update is another operation or the method. So here self, as you know, self will be the reference to the object that I am working on currently. Name and age as the two arguments, position arguments you have to pass. And s1 dot name will be updated with name. Sorry, this should be self actually. It should not be s1. There is a typo there. It should be self dot name and self dot age. Okay. All right. And then when you have called display function, it will display ram and 5 on line number 10, because s1 is object whose name is having a value ram and age having a value 5. S1 dot update. When you are updating with when you're calling update method, you're passing only two arguments while update takes three arguments. No problem, because the very first argument Python will interpret s1 dot update ramu comma 6 as what? Student class name student dot update s1 comma ramu comma 6. So no problem there. Okay, this is very important thing out of all entire session, because if you understand this, most of the things you will be having them very clear in your mind. So what happens, I have some class. Okay, inside that class I have a constructor, I have other methods as well. Here display and update are methods within that same class. And if you have created an object, okay, of that class, s1 is equal to student ram comma 5. Okay, object is created. What happens when an object is created? A constructor is called, right? So what happens from the memory point of view? So some memory will be reserved to store this object, and the constructor, what it will do is, in the context of this line number 9, self refers to s1. Self refers to s1. So ram is what name it is, right? So in the name of this name of this object, under the name attribute of this object, the literal or the string ram will be stored. In the attribute age of s1, 6 will be stored. That means you are constructing the object, you are allocating the memory for that object, and you are storing that object physically in the compute memory ram. Okay, you have created one more object. What happens now? When you create one more object, separate memory will be allocated. That means whenever you create an object, it will consume its own memory. Okay, hence you can have its own state. So we talked about state some time back. What is that state? When it comes to object 2, the name would be Shyam and the age would be 7. And S1 dot display and S2 dot display, what how they will work, and how do the member functions know the context is what I'm going to explain now. First thing, class we have seen. What is a class? Class allows you to club attributes and methods into single programmable unit, and you reused this existing class. Why? Where did you reuse this existing class? Or existing means you have written this class. Whatever class you have written, where did you reuse it? You have reused it to construct or create multiple objects. Here you have created two objects, no, using that same class. So it is a reusable unit of code. What is its speciality? It will club the things together. What are those things it can club? It will can club data and operations or the methods. Here data means attributes, operations are the behavior or the methods. These are nothing but methods actually. Okay, now once you create object to a class, what happens? Memory will be allocated for that object. As you see here, s1 is the name of the object, name and age are the attributes. So name got a value ram, and age got a value 6, because that is how you have initialized it. Similarly, when you create second object s2 on line number 10, what happened? Separate memory has been given to s2. That's what a separate block, as you see here on the right hand side. And the name has been updated with Shyam, and the age has been stored as 7. Now on line number 11, when you call s1 dot display, what happens? When you call s1 dot display, for display method, self will become s1. That is a important thing that you need to understand. Self will automatically become s1. Why self will become s1 in that context, because on line number 11 when you are calling display you have used the object s1. So Python will internally consider s1 as a very first argument to display function as s1. So s1 dot name and s2 dot name, of course display also has a typo. It should be self dot name and self dot age. Sorry about that, I'll correct it. But s2 dot display will have the self pointing to s2, and that is how you have multiple objects. You have many objects, but at least in this example you have two objects only. Both those objects having different memory allocated. So when you are calling methods on those particular objects, there is no any confusion here, because every object has its own dedicated memory here, as long as it is within the scope and it has lifetime. So s1 dot display, when you call s1 dot display, it goes to the place where memory is allocated for s1. Their name refers to s1 only, name, because that's why attributes repeat in each and every object, but the values of the attributes can be different for two different objects, right? So that's what happened. All right, this is how the memory allocation happens. And if you create one more object, a separate somewhere else, this is assuming that this entire blue color thing is a memory of your ram. Okay, random access memory, I said, I mean. And when you are creating objects, this is how the objects will be, the memory will be created for the objects. Okay, now with this you should be able to have good understanding of every concept that we have discussed so far on object oriented programming in this session. We talked about a class. What is a class? Class is a blueprint, we said. Why we call it as a blueprint? Because using that class we are able to create objects, similar objects, but only difference is that these objects can have different values for their attributes, but the attributes are uniform. S1, how many attributes does it have? It has two attributes, name and age. How many attributes S2 has? It also has two attributes, name and age, because these two belong to the same class. If you keep adding these attributes dynamically, there is a problem. What is the problem? There is no guarantee that every object belonging to that class, to the same class, have the same set of attributes. No one can guarantee that. That is why the suggestion is to use constructors. So we have gone with constructors. Constructor is a special function which will automatically be called whenever an object is created. So what is the best place to deal with attributes? The best place to deal with attributes is constructor only, so that every object will have uniform number of attributes. That is a key thought process behind coming up with some special function called a constructor in object oriented programming. Now you create S1, you create S2, you create S3, doesn't matter. All those objects will be having the same set of attributes, because now it's the responsibility of the constructor in Python to have all those attributes available for that given object. Okay, so class groups together or holds both attributes and methods together, or attributes and operations together. What are the operations? Operations are nothing but the methods or the state. Operations are nothing but the operations that you can, methods are nothing but the operations that you can perform on the attributes. You see, display, it works on the same name and age. Update works on the same name and age. That means methods are working on the attributes. Make sense? So that is how, again, a class is a blueprint. Class is used to create objects. Class is used to support encapsulation. Encapsulation is the process of clubbing the attributes and methods together into a single programmable unit. And class is what it can do. And class is what this can be achieved by. Once you create a class, you create the objects. And once you create objects, you will call the methods using those objects. Every object, when you have created it, will get its own piece of memory available in the uh, random access memory or the computer memory. And now what is a state, right? You see, S1 at the given point of time S1, it has a name as a Ram and age was a 6, right? That becomes the state of that object. If you call update on S1, say you say S1 dot update, right? You change it to something, then its a state has changed. But how were you able to change the state of the object? Through a method, through an operation, right? Only method can change the state, no? So methods are used to change the state or dictate the state. You can say that, okay, be in this state. You can force it. What is a state actually? You can say that you have your name as Ramu and age you are 7. That's all. You are instructing it through methods. So methods operate on attributes, and attributes are just the properties of the object, right? And every object, when it is in the memory, it will maintain its own state. State is simple. Every attribute value of that class, right, that reflects the state of that object at that particular given time. If you call s1 dot update and pass different values, again the state of that object changes. So to change the state of the object, you have to rely on methods. That's the importance of method. Sometimes you may not change the state also, but you may have to grab the value. For example, display just simply has to access the values and just show it on the screen, or it has to do something, some processing, right? In such a situations, display is the, again it's a method only. Still it is a method. Display is also a method, okay, because it is written inside the class. It is a method now, okay, but it doesn't change the status. But these are nothing but normal operations we say. Okay, state means they can change, and display means display kind of functions will just get the inquire the status or the current state of the object, and it will just report it here, right? So when you call s1 dot display, control goes to display method, self becomes s1, go to the place where memory is allocated for s1, look at all the attributes of s1, name, and yes, name is printed. S1 also has some other attribute called age. Age will also be printed. The same display function, when it is called by S2 object, S2 object line number 12, self becomes S2, and go to the same display function, but self becomes S2. The very first step is to go to the place where memory is allocated for S2. Well, I reached S2. Then find out if you have an attribute by name. Yes, it will be there obviously. Print the value. Check whether you have an attribute by name age. Yes, it is there. Read the value of that. It is 7. So print it. This is how you will implement method only once, but that method can be called, or that set of methods can be called multiple times by multiple objects. And I have also shown you you how you can call a method using class also, but we generally don't explicitly do such calls. But just for your understanding, I have covered that as well. And self has no significance. The name self has no significance, but self has a lot of significance. Without self, you cannot write a member function, because every member function expects that self to be the very first argument automatically. That's why self has to be the very first argument, or its representative name. We need not be self only. No, it can be x, y. I have shown you that, right? But always remember, the very first argument to a method will be assumed to be the name of the object that is being used to invoke that method. So what is the state of the object? The state of the object refers to the current values of the attributes that belong to that object in the memory. How do you change the state of object? Again, by making the calls to respective methods. First, you need to understand what you need to change. You want to change only name, only age, or both. Here I have used, we have written an update function or update method to update both of them. But again, you can customize it. I want to only update name. I want to only update age. Different methods you can write inside that same class, and you can call appropriate method for your job to be done. Yeah. So a class is a blueprint, or class supports encapsulation. Class is a programmable unit which will club both data and the attributes, data and functions together. Data means attributes. Okay, functions are nothing but methods, or operations are nothing but methods. Functions and operations, anything. So class is nothing but that unit, single unit, piece of unit of code that can help us to group or combine the data and the operations together. Okay, what is object? First of all, object is a variable of type class, or the class variable is nothing but object. Okay, you know what is a class, you know what is an object. Okay, what does an object represent? Object can represent a real world entity. So here S1, when it is in available in memory, it represents one student programmatically. Okay, you know what is encapsulation by now. You know what is a class, what is an object. Okay, and you know what is a constructor. Constructor is nothing but a special member function that is used to initialize the attributes of objects. It also guarantees that every object has same set of attributes. That is the constructors. What is the state of an object? When you create an object in memory, sorry, when you create an object in your program, memory will be allocated, and all the values of the attributes of that object will be maintained in that same memory, and the values of those attributes will be updated with what you have been passing to that constructor at the time of object creation. So that value will be assigned to those respective attributes, and that memory will be associated with that particular object only. You create one more object, a separate memory will be allocated, but the same attribute list will be there, because S1 has the attributes name and age, S2 also has the attributes name and age, because both of them have passed through the same constructor, both of them belong to the same class. However, the values of these properties are different. For S1, name has RAM, name is Ram, age is 6. For S2, the same name attribute has a Shyam and age is 7. That means values have changed, but the set of attributes did not change. So the state of the object is defined as the values of the values of its attributes at a particular time, at a given time. How can you change the state? Changing the state of an object is nothing but changing the values of its argument, changing the values of its attributes only. You call update function or write like that. Okay, how do you access the values of an object's attributes? By calling this display function or something like that. Okay, so this is how you can program and you can model any real-time entity. You can first you have to think, what are the details that I want to store or maintain about this entity. Yes, go ahead and first create a class. Then think of what are the operations, or how I want to control this how do I want to control this entity, what are the operations I want to perform. All those will become methods. Create object. Object reflects the real world entity, and from there on, if you have to change the state of that particular entity, call the respective method which is responsible for that. That is how you can maintain the updates or the current status or the latest status or the latest state of the real-time object into the memory in the programming. This is how classes and objects will help you to model any such things. Okay, why class? This is final slide for this session. So reusability, you have already seen what is reusable. How can you reuse the same class? Class is reused for creating more objects. That is only one aspect we have seen today. In the subsequent live session, I will show you how class can be reused with the concept of inheritance. And class supports modular design. So you already know what modular design means, breaking the big problem into small pieces and implementing them. So you did not really tackle this school management system in one go. You have first identified the sub parts of that, and you have used different classes to deal with different types of sub problems here, or sub entities or entities. So student separate class, teacher separate class. That is how it supports modularity. Easy to organize. Of course, if you have to add some extra feature to student, you can very well do. You know that you have to go to student class only and do the changes. You need not worry about the rest of the four classes available. That is how it is easy to manage and organize, right? Easy to maintain. Maintain means once you sell this product off to someone, some client, okay, there are some bugs, or they need some extra features and all. If they ask some extra features in a subject, then you have to go to subject class and see what are the related changes you need to do. Do you have to support new operations, or do you have to support new attribute to maintain more data about some subject? All those things you have to think, and accordingly you can enhance it. Easier teamwork. This is again wherever there is a modularity, the parallel development can happen. Different teams can work on different pieces of the development, and you can complete the development parallelly quickly, because parallel development is possible. Real world modeling, as I just said, which would be very close to real world modeling. That object is very close to real world modeling, because object maintains a state, and you can change the state through operations or the methods. Secure, again, security wise, again, once you have the data within, for this you need to understand what is visibility label and all that we'll be covering in the subsequent session. However, once you store the data in a class, okay, it is not accessible by any other outside function or anything like that. You have to create an object. Through object only you have to do that. From that sense, anything that you write inside the class, and there are other techniques, are the visibility labels that you can they can visibility labels are through naming conventions only in Python. Using some naming conventions, you can control who can access the attributes, set of attributes, okay, from different places of your Python program. So that way the data would be secure if you use classes. These are all the advantages of classes. All right. With that said, we have reached the end of the session almost. And before I wind up this session, I would like to introduce our website again for those who have joined new. Just quickly. So, this is our website. You can make a note of this: technolonit.com. All right. So, I would strongly suggest you to go through our website and understand who we are, what we offer, so on and so forth, and you can go through different details, right? What courses we offer, and if you want to get in touch, there are different ways you can contact us: WhatsApp, phone call, or we are also available on multiple social media platforms. And I would strongly suggest you to subscribe to these social media platforms and be in touch with us. Okay, and most importantly, for the ones who are attending this session for the first time, this resource page has all the details or all the resources that have been used for these sessions. So you can download these resources and you can make use of them, and you can become better Python programmer. Okay, and the same page also has the information about the next live sessions, their date and time, so you can keep an eye on this page so that you don't miss any live sessions that are scheduled, and you can learn more from it. Okay, all right. And the next one I want to really introduce is this Technolearn YouTube channel. I strongly encourage you to subscribe to this primarily because you'll be getting the daily quizzes, and these are the live sessions that have been held in the past. Everything will be available here, and you'll be getting daily quizzes. These quizzes are posted on a daily basis. Okay, so once you subscribe, you'll be getting these quizzes, and these quizzes are very short, less than half a minute. So you can just watch these quizzes, and I will strongly encourage you to watch these quizzes till the end, so that at the end the answer will be revealed. So you can just guess your answer, and you can compare whether your guess is right or wrong. Okay. This enables you to be in touch with the topics or the subject, and these quizzes will also help you if you are going to face any written tests and all, because most of these questions are from some interviews that have been already conducted by some MNCs. All right. So that's what I want to cover before we conclude the session. And let's jump back. Yes, this brings us to the end of the session. And the primary objective in this session was to introduce object oriented programming, primarily the class, object, constructor, methods, okay, encapsulation, state of object, okay, and different operations that we can perform using objects. How can we model a real world problem in programming is what we have covered. So technically what you need to do is you need to just have all one class for each of those entities that we have looked at. One class for student, one class for teacher, one class for classroom, one class for subject, so on and so forth. A simple example for you to understand is, say for example you have two numbers and you need to perform four different operations on it: addition, subtraction, multiplication, and division. You can now do it through class. How? What are your attributes? Attributes are next number one and number two. What are the operations now? Addition, subtraction, multiplication, division. You can implement these methods, four different methods in the same class, and that's all. If you have to perform addition, you first create an object of that class, right? And then call addition method. Okay. If you want to multiply, you call a different method. That is why you are performing different operations on the attributes. Here the attributes are nothing but number one and number two. As simple as that. Okay. With that said, I'm going to conclude today's session.